Well, hello friends, and Merry Christmas. Welcome back to the program. Today we are going to keep playing FIXME Roulette because it's the game of the season. And if this is your first time playing, the way it works is that we get grep for FIXME or to do in the Serenity codebase. And then we shuffle that so we get a single item to work on. And we're pretty far into this series now, but we keep fixing nice stuff. So let's continue and see how it goes. So we are selecting from 5,428 FIXMEs, but today we are going to be working on it. Virtual file system. FIXME, we should return e not empty if the last component of the path is ... All right. So this is an rmdir. Okay. So it seems like there are two situations here actually where I guess we don't return the right error code. E inval if the last component of the path is ... and e not empty if the last component of the path is ... Huh. There's an e not empty here. But I guess that is if the directory has more than two children. So an empty directory on Unix has two children, ... and ... So, but if it's not two, then it's not empty. Okay, I mean, I guess we can implement these, but I wonder where does the idea come from that these are correct? FIXME was at, oh my goodness, 2019 January. These are some ancient FIXMEs. Look at that. Can we get that out here? Let's add support for removing directories. Okay, so this is like when the project was about 3 months old, is when I added these FIXMEs. So now we are doing some real FIXME archaeology here. But it's going to be awesome to fix these. So I wonder why we got the idea though. So let's look at POSIX rmdir. Maybe POSIX can tell us what we need to return. Let's just make sure that we have the right version of POSIX. Okay, so rmdir should fail if, and then a bunch of situations. So we were talking about e inval and e not empty. So e inval is the path argument contains the last component that is ... So that seems straightforward and it's like something we should do. E not empty. Virtually all existing implementations detect e not empty or the case of ... Wait, what? If the directory is not an empty directory, rmdir shall fail and set error note to e exist or e not empty. Oh, so you can choose which one you like. E exists or e not empty. The path argument names a directory that is not an empty directory, or there are hard links to the directory other than ... or a single entry in ... There are hard links to the directory other than ... or a single entry in ... Okay. So let's see. I guess we can start with I guess if we just suss out the last component of the path. So would we get that from the custody, I wonder? I feel like we're not gonna. We should probably split on the path ourselves. Wait, can we get the path components? So resolve path will look at the path components. Path trim. Wait, what is this thing doing? It's trimming any trailing slashes. Wait, what? Oh, okay. But I want to look at the, what are we calling them? Parts? Path parts? I'm just thinking, like, what kind of API do we have? We have base name. Maybe we could use base name to figure out. I don't know if that's the right thing to do. We need some kind of API here that doesn't allocate, preferably. Okay, let's see what resolve path does. It calls resolve path without veil and path elixir. Okay, so it doesn't do a split anywhere. All right. Let's see. Last component, let's just see if we can extract it using some kind of trickery like this, right? So base name of path, and we'll log it. Path is last component is let's see. This should be fairly straightforward to test, at least, because we can just like rmdir x, right? And then oh, if resolution fails. Okay, so it has to be something that exists. Okay, so if I say dot, then path is dot, last component is dot. Okay, and foo bar dot. That doesn't resolve, of course. Home and non dot. Last component dot. Sure. So that seems to be doing what we want, getting the last component. What if you did something like dot slash, still get slash, oh, still get the dot as the last component. If path is empty, then return single dot. That's a little bit weird. So if you do that, but that will just get failed earlier. So I think it's okay to do this. Yeah, I think so. We should be able to use base name for this purpose. Okay, so if the last component of the path is dot, and for dot dot e not empty. So what happens right now if you try to, I wonder what happens right now if you try to remove dot dot. Well, permission denied, sure. So let's make a structure like this, and then rmdir dot dot, directory not empty. I mean, how would you ever, like, if dot dot is a thing, that means that somebody, that you're like inside of some other directory, right? Your parent directory will have a link back to you if you have a dot dot link back to the parent. So I feel like this already kind of works because we don't need to check for dot dot. Because if dot dot exists, that means that we are somebody's child. And if we're somebody's child, then referencing the parent via dot dot means that the parent will not be empty because there's a child. So I feel like this is already covered by this check here. I think we can get rid of that FIXME. What about this one though? If the last component of the path is dot. So we're in here. So if I do something like home anon foo bar dot. So wait, what? Wait, bar is still here. What's in bar? Wait, what? Stat dot dot? There's a file dot dot. That's strange. Where are the files? Where are the dot dots? Yeah, so this thing is in a really weird state now. I wonder if we do a E2 FSCK on the disk image, it will complain. Yeah, first entry should be dot, not dot dot. So we've corrupted the file system. Bad inode number, second, yeah, everything is all screwed. Okay. And the ref counts are bogus. So we can make quite a mess of the file system here by just deleting dot inside of a directory. So we shouldn't allow you to do that. Let's see that we understood the problem right, though. Right, I just want to check that like removing the dot is what the problem is. But you should absolutely not be allowed to do that. So this should fail in this way, right? We'll bring that in momentarily, but let's try it out without that fix. Okay, so what if I can't do it here. Permission denied. But I can do it here, just rmdir dot. After I do that, then the file system is screwed in multiple ways. Very cool. Okay, so now let's enable our little fix. It's funny that there are like trivial ways to corrupt the file system from within Serenity. And they've been like a FIXME since 3 months into the project, and we're just getting around to it now. But that's okay. That is perfectly okay. Okay, let's test this out again. So rmdir foo dot. Invalid argument. You can't do that. Haha. Right. So you can't do that because it's not empty. You can't do that. It's invalid. Foo bar or bar dot dot. Not empty. Cool. So we are preventing these issues, and an FSCK says file system is not corrupted. Great. That's fantastic. So here, I think, let's see. So enval, let's copy this stuff from the spec just to make it ultra clear why we're doing this. Okay. That's pretty good. And make a test for this also. Do we have something like test rmdir? We have some rmdir. rmdir while inside dir. Oh, interesting. So we have some tests for rmdir, but evidently not for rmdir dot, which should just give you enval. So let's add a test for it. Home anon. Does that thing get removed by the end here? I guess it doesn't. We'll just call it something like that. rmdir test 1. Sure, whatever. Okay, and then we want to rmdir home anon rmdir test 1 / dot and verify rc is 1, or it should be non-zero, I guess is the POSIX way, and erno should be enval. And if we cd into it and do rmdir dot from there, let's just test for that as well. Okay, let's see if we can run that test. Would be nice. So this would be test.io, it's called. So user tests, libc test.io, rmdir dot, succeeded, cool. Let's also be good boys and delete the directory here at the end by doing that, which should succeed. Otherwise we have a thing sticking around, which we don't want. Go away. All right. Oh, that didn't succeed. Line 323. Oh, I guess because it's already there from the, no? Okay, no, it works, it works, it works. It was just remnant from before when we didn't clean it up. Okay, good. And then let's add that to the test as well. Yeah. Kernel plus tests. Make sys rmdir fail with enval if path ends with dot. If a base name is dot. Dr. POSIX says that we should fail, we should reject attempts to rmdir the file named dot. So this patch does exactly that. We also add a test while we're here. We also add a test. That's good enough. All right. And then we had the other situation. Or you know what? I'm going to brag about the really old FIXME. This solves a FIXME from January 2019. That's pretty cool. And then we got this other sucker, and I'm pretty sure not empty. The path argument names a directory that is not an empty directory, or there are hard links to the directory other than dot, or a single entry in dot dot. right. So the way I read that is like the directory is not empty. Although, what if you have a different hard link to the directory? What would Linux do, I wonder? So like if we make a foo directory here, so we make bar, and now bar is right here. Can I make a hard link to bar and call it baz? Hard link not allowed for directory. Yeah, that's what I thought. So I wonder if we enforce that. By the way, let's find out. I'm not sure. So all ln bar baz not permitted. It's probably the right error. Hard link not allowed for directory. I'm just wondering if that is a special error no code. I feel like that's might be like a bash clarification. I don't know if, or it might be ln saying it rather. ln. Where's the source code for ln? Here, hard link, not, yeah, so it comes from ln. They make like slightly different errors based on the state. So that makes sense. I was just checking that we didn't do anything wrong by saying eperm. Okay, so e not empty. Already taken care of. You can't delete something that is not empty. So clook, clook. Let's get rid of that. So e not empty. We can have a test for it though. We can absolutely have a test for it. We currently don't test for that, so rmdir. Oh, a message from my mom, who is doing just fine. Let's see. So let's do something similar here, except slightly different. Just make a new directory. Try to remove the dot dot. I guess actually let's make something like this. Foo dot dot. This should fail with e not empty. And then removing it like this should succeed. And removing the test like that should succeed as well. So I think it's good to add the test for it just to make sure that it works correctly, but the FIXME I think we can just get rid of. Test IO, look at that, works just fine. Cool. Tests, remove inaccurate, or inaccurate FIXME. Sys rmdir. We were already handling the rmdir dot dot case by refusing to remove directories that were not empty. Nevertheless, this patch removes a FIXME from January 2019 and adds a test. Although now I kind of want to just reword this previous commit message and add a period there just to make it a proper sentence. Okay. So what are some nice things we can do while we're here? Just something that stood out to me is that these are not commented. So let's just add some spec copy comments here for the motivation for each error. So rmdir, component of path, names an existing file that is neither a directory nor a symbolic link to a directory. Sure. Busy, no parent directory. Wait, what? The directory to be removed is currently in use by the system or some process, and the implementation considers this to be an error. Wait, what? That's an odd error. I added that. Oh, rmdir slash. Wait, what? I mean, slash is always in use, right? But it doesn't necessarily feel like it maps directly to that. Or wait. What does this mean? If no parent custody, the root does not have a parent custody. So I guess that is actually that. Well, we could expand on the comment a little bit. So we'll do this, and then we will expand on this and say, note, there is no parent. That means we're trying to rmdir the root directory. Yeah, so that's healthy. E-access, search permission is denied on a component of the path prefix, or write permission is denied on the parent directory of the directory to be removed. So if we are not allowed to write into the parent, then that's an E-access, absolutely. And if search permission was denied earlier on, we would have failed in resolve path, because resolve path checks for search permissions when traversing the directory tree. Okay. And then E-access here for sticky directories. Here, sticky bit. So E-access or EPERM, the sticky bit is set on the directory containing the file referred to by the path argument, and the process does not satisfy the criteria specified in directory protection. If a directory is writable and the mode bit sticky is set on the directory, a process may remove or rename files within that directory only if one or more of the following is true. This, and that conditions. Right. So this is just enforcing the sticky bit behavior. The effective user ID of the process is the same as that of the owner ID of the file. That is what we are checking here. The effective user ID of the process is the same as that of the owner ID of the directory. Wait, does that mean that if you own a directory, if you own a directory, it's your directory. So if you own the directory, it's your directory, you should be allowed to delete from it, right? Even if it's sticky. Let's see how that works on Linux. Okay, so let's make foo sticky. Okay, so now foo is sticky. We got the sticky bit, and then root directory. So now root has a directory here, but I should be allowed to delete that because it's my directory. And I can, but will that work on Serenity? I wonder. Let's test it. Okay, so we got a foo, Okay, well, we make foo sticky. Okay, so it's sticky and it's mine. And then root steer. Can I delete root steer? I cannot. That's not correct. I should be allowed to delete that. I can't RM it, but I should be allowed to rmdir. So we have a bug. Here. So if the sticky bit is set, let's see. E-access. That's a little bit of a mouthful. Maybe we can split these like that or something. Okay. By the path argument and oops. Okay, so the sticky bit is set and the process does not satisfy the criteria. So if we're not the super user, we don't own the file and we don't own the directory. That was the thing, right? So if the user ID, effective user ID of the process is the same as the owner ID of the directory, that should be okay. Yeah, so parent inode, metadata UID is not credentials.euid. Yeah, I think we'll write it like that. Now I should be allowed to delete that thing. Look at us finding ancient problems and fixing them. Isn't it nice? Haven't looked at rmdir in forever, so it's a good thing that we put it under the microscope here on the FIXME Roulette show. Okay, so we're still sticky, and we got root steer here, still owned by root. Can I delete it? Yes, I could, because it's my directory. My directory, my rules. Okay, so that's good. We'll make a test for that momentarily. But first, let's see what else we got. What else we got? E not empty. So let's put a thing about E not empty. Just annotating the errors that we do have. Cool. Read-only, erofs. The directory entry to be removed resides on a read-only file system. Honestly, that feels like something we could check earlier, but I don't know if it matters. POSIX doesn't tell you which order to check these things, which is probably like a source of inconsistency between different Unixes. But since nobody has made any effort to like document or tell you, because these are just in alphabetical order, and maybe they want you to do it in alphabetical order. But since nobody says which order to do, I just assume that maybe doesn't matter that much. Of course, there's probably something somewhere that relies on the specific order of like Linux error checking. Who knows? Okay, so I think those are the errors that we have. Are we missing something here? Enoent that's checked by resolution. eloop checked by resolution. EIO can occur anywhere. and it will just bubble up through the error propagation mechanism. And the other ones we are checking for name too long. I think that's handled at the outer layer. So when we do get syscall path argument in the syscall handler here, I think that will raise ename too long for too long paths. Yeah, which might be silly. May fail, shall fail. So I think it's not actually necessary to fail for this. And you could argue that we shouldn't. Because what if you want to have an obscenely deep directory structure? Like, why should we artificially cap you at path max? But that's not what we're here to look at today. But it is an interesting issue. Path max is kind of an arbitrary constraint. Anyways, so let's add these in a commit. So we'll do the ones that we're just adding the comments. So not the one where we're actually fixing a bug. Kernel annotate virtual file system rmdir with spec comments for errors. Errors with spec comments. Yeah, that's interesting. In fact, we could even, I was going to say we could even link to this thing like this, right? Yeah, let's do that. It's helpful. Okay, and then now I just want to what is it I want to do? I wanted to make a test for this scenario, right? For the sticky bit thingy dingy. So it's a little bit convoluted, but I think we can do it. So let's see. The problem was that we were not allowed to delete stuff even though we owned the sticky directory. rmdir someone else's file in my sticky directory. Okay, so we'll make a sticky dir. And can I make that, by the way, and just make it sticky myself? I can. And then could somebody else go here and make a directory? Hello? Of course they can. And now I can delete their directory. Haha. Of course I can. Good. This is going to be a little bit of a hassle to test because we have to do user switching, but let's see if we can do it. So we just want to make that directory and then make it sticky. And then at the end, we will delete it. Okay, and then at this point, we want to well, we want to make a separate process and tests run as root, do they not? Or not? I mean, we can only do this if we are root, actually. So note, this test only works when run as root. Since it has to perform user switching. Wait, I don't need to do user switching, do I? I just need to make a file that's somebody else's. I don't need to switch the user for that. But it has to chown file to someone else. Yeah, so I just have to make a directory to someone else. So we will make sticky deer, not mine, and then we will chown that to somebody else. Chown. We will chown it to my user ID +1, I guess. Does that work? Sure. So if get UID is not 0, then return. Yep. Okay. And then I should still be able to delete that. Although, oh dang it. I do have to make a user switch, because if I'm root, it will just succeed no matter what, because I am root. Root can always delete directories. We are super user, so shoot. Okay. So we make the thing as not mine. And then I guess I need to, here, I guess we can fork. PID is fork. Verify PID is greater than or equal to 0, just so we didn't get an error. Okay, so if PID is 0, that means we are in the child. So here we want to set UID. Okay, so I'll just make up some arbitrary things here then. So sticky deer should be owned by it will be owned by 1, 2, 3, 4, 5. And not mine will be owned by 1, 2, 3, 4, or no, 2, 3, 4, 5, 6. Okay. And then we fork, and then we want to set UID to 1, 2, 3, 4, 5. Okay, so now we are 1, 2, 3, 4, 5. And we want to delete it, and it should succeed. Okay, and then here we can just exit successfully, right? But in the parent, we need to wait on the child. Not mine. I forget how to do this. Is it wait PID? So we wait PID for the PID. Status and options 0. Because we do want to hang until it finishes. And then deleting this should work as well. Okay, I wonder if this will actually work. I feel like I'm forgetting something here, but we'll test it. So test.io, if I just run test.io like this, I'm running it as myself, so it will just skip this test. But if I run it as root, test.io, We fail. 471. Wait, what? 387. Let's look at that. 387. I cannot delete this directory. Sticky deer, not mine. Oh, wait. Sticky deer is T, owned by 1, 2, 3, 4, 5. What's in there? Sticky deer, not mine. 2, 3, 4, 5, 6. It's in there. It's all good. Maybe I have to do set EUID. Let's try that again. User tests, libc test IO. 387 failed. So we're not able to nuke home and on sticky deer, not mine. I can't become that user. Oh, that's a little bit annoying. I'm just gonna go ahead and add it to the password file, because we currently, I think you can't, just SU to an arbitrary user ID, but maybe that's something we should support. Let's see that again. So become root. Okay, so we come. Oh, it doesn't have a shadow entry. Come on. I mean, these are very reasonable complaints. Just let me in. I guess, I mean, we could log why it fails. So erno. I would be interested to see why it fails actually. Okay, erno 13. Permission denied. All right. And what's the situation here? This is owned by FIXMEs. rmdir, not mine. And I'm perfectly allowed to do that. Home and on sticky deer, not mine. And child process, get you EUID, will rmdir. Okay, so in child, I'm 1, 2, 3, 4, 5, will rmdir, but it doesn't work. And then 399 fails. I guess because it's non-empty, but why do we get eperm? That's unexpected. So my EUID is 1, 2, 3, 4, 5. Do I have to do like one of these things? What if I set my real user ID also? Maybe there's some check earlier in the chain. Because we're only testing for EUID. $384 failed. 384. Set REUID fails. Wait, why? Why do you fail? Why does it fail? I don't remember how these things work. Okay, so if I am the super user, shouldn't I be allowed to become anybody? What does SU do? SU will do simulate login, authenticate, account.login. Okay, set GID, set UID. Set EUID. Where do we do that? I am a little bit weirded out. Let's see. So we're getting e-access. And why are we giving out e-access? It's because we are in, where are we? Virtual file system. I guess we can log here. So e-access and sticky dir because is super user UID inode UID you know what, let me just log all the things. Parent UID. We can divine it from looking at all this. Credentials, UID, parent, UID. All right, just let me see it. Just gonna take off the hat. It's a little bit warm. Then, what is your problem? Okay, so what were we logging here? Someone else's. Oh, wait. E-access and sticky dir. Am I failing earlier? Write permission is denied on the parent directory of the directory to be removed. Parent may write. So is it that it believes that it's not allowed to write into the parent? Or am I just getting distracted now? 384. I mean, this call was already failing, so let's do this. Right, I have to get back on track here. Okay, so we have the right EUID, we will rmdir, and then 389 fails, so this call fails. And we should see something in the debug output, but we don't, just see failed test. So is it that we are rejecting it here? Because parent metadata says we cannot write with our current credentials. And our current credentials may write. Our current credentials, I mean, they're not allowed to write because It's not our directory, and we're not super user. But I feel like for sticky, we should use the other. So this should be like this, right? The access permissions are handled differently for sticky versus non-sticky. I think that's right. So for sticky, then we honored the sticky bit by doing this type of check. Otherwise, for non-sticky, we honor the regular permissions by doing a full check. I believe that's correct. Sticky. Okay, where are we failing now? 389. 389. So we're still failing here. Will rmdir. We're still getting e-access. It's not logging anything. What? E-access número 2. I'm confused by this e-access error that we are currently getting, I have to admit. I don't know where it'd be coming from, so let's at least just log it out. We're not printing that thing either. Cool. So we're still failing on 389, rmdir. Getting an e-access, but it's none of the two that we have logging for. This is rmdir. Wait, are we like not even able to see this directory if we are 1, 2, 3, 4, 5? So home. Oh, we're not able to be in here. Oh, interesting. That's an issue. Then it's gonna e-access during path resolution. I didn't even think of that. Okay, well, that's stupid. We can just put the test somewhere else. So we can just, instead of home and non-sticky dir, we can just put it in temp. So we'll just do that. Okay, I think it may have worked, although what's going on 474, that's something else. Syskernel processes. Should give you e-access if you try to open it read-write, but apparently we're getting a different error now than expected. Is that it? Getting e-inval instead of e-access. So it might be one of those error code ordering things when running as root, because when we're running it normally as a user, then we don't get the problem. Okay, so at this stage, I think this is sort of the best effort version of this test. So I'm gonna put it in like this. Create temp sticky dir and a sticky directory owned by 341, 2, 3, 4, 5. Then create temp sticky dir not mine, a normal directory owned by. Then fork and set UID to 345. Try to rmdir the not mine directory. This should succeed. The parent, wait PID on the child, and finally rmdir temp sticky dir. Yeah. Okay, just so that if somebody's looking at this, they can understand what it's trying to do. Let's get rid of those. And then we had a bunch of debug logging while I did not understand what was happening. But I think this is still correct, because if we had this out here, then we should e-access incorrectly. So let me check that that was actually, that I had the right idea about that one. So if I run now, it should fail. rmdir someone else's sticky directory. Wait. It doesn't fail. Why may I write to the parent? Oh, is it just because it is writable? Sticky dir. Wait, it's my directory. So of course I can write to it. Right. I just can't delete someone else's thing. It's my directory. But what if it's my file, but not my directory? So can I delete my file in someone else's sticky directory? So let's see. I mean, I should be allowed to. Yeah, because otherwise /temp wouldn't work. Yeah, so that's just normal. Okay, yeah, so we didn't need that change. That was just me thinking the wrong way. Okay, it's funny when you try to write tests for these things and you kind of you're forced to think a bit deeper about them. And I probably missed something here that I'm still forgetting or whatever. So if you have suggestions for how we can improve this, or if you notice something that we missed, then please add a comment on GitHub about it. There will be a link to the pull request in the video description. So let's see, kernel plus tests. Allow deleting let's see, what were we checking? We were adding was it my thing in somebody else's sticky directory? I'm totally forgetting. Someone else's file in my sticky directory, right? Someone else's file in my sticky directory. Okay. This should be allowed according to Dr. POSIX. Cool. Okay. So that's a respectable haul, I would say. Got some, I mean, we hit a bit of a dud of a FIXME originally because that error was already being raised, but we had an enval, which fixed file system corruption. We annotated the other errors with spec commentary, and then we found an incorrect behavior in the sticky flag on directories. So we are now allowed to delete other people's files, other people's directories in our own sticky directories. So nice little progress. There's probably 100 other things like this that you can find if you go and investigate other areas of the code. So you are cordially invited to do that if you find that sort of thing interesting. But this will be the end of today's video. So if you made it this far, then I thank you for watching and for hanging out. I hope that you saw something interesting. I certainly enjoyed hacking on the kernel a little bit and fixing up some ancient FIXMEs from January 2019. And it's good that we can't trivially corrupt the file system by doing rmdir dot anymore. So thanks for hanging out, and I will see you all next time. Bye.